All right, so got to finish chapter 7, don't we? First. So we did the bone card game, and I know y'all all got together yesterday and played it more, right? Because it was so fun. Made your whole family play with you. That's no excuse.
Maybe I'll do it. I'm going to take them home with me then.
Yeah.
Make her play. You're going to learn both of me.
All right. I'm actually glad I'm at school today because my daughter's getting potty trained today, supposedly. So this is a much better place for me, I think.
Yeah, we haven't quite mastered that in our house yet, but that's because Mom's not home.
Yeah. Hard to believe.
My cousin was potty trained 14 months, though. That's really true. Do you think it works easier if you do it sooner? I don't know. She just wanted to do it. She just
That's crazy.
like one of those weird kids that was just like, I'm gonna go potty on the potty.
Mhm.
Okay. There you go, dude.
All right, so here's our spinal column. You do have 26 vertebrae as an adult. And they're divided into 5 regions, 4 curves. The only confusing thing, slightly confusing thing, is the numbering. So they number each vertebrae by the region it's in, and then they start the numbering over for the next region. So you probably heard like the C4 vertebrae, that's cervical vertebrae number 4, or thoracic 9, that'd be the 9th vertebrae in the thoracic curve, or the thoracic region. So you've got cervical, thoracic, lumbar, sacral. The sacral vertebrae actually, when you're born, they're not fused together. They actually have the cartilage between them, and then later on in life they do fuse together to make that one sacrum piece there. All right, so which of those lists the order correctly from superior to inferior? I guess I didn't turn this on. All right. Oh, sorry. Y'all have a bunch of extras on your tables. Can you pass them back there? I moved them because we were doing lab stuff. A, and you're right there. So C4, C7, T2, T11, L2. Right. Now, what's interesting about our vertebrae is they are connected by joints, but then also, we'll talk about the joints when we do the joints chapter, but they also have an intervertebral disc between them, which you saw back. These little Oreo cream fillings right there for each of those. Those are those invertebral discs. There you go. And these are very important because think about how much weight is on your spine all the time. You can't just have the bone with a little bit of cartilage or something. You need something to really absorb all that weight. And and it's made of fibrocartilage. We're learning about that in chapter 4. And then there's also a layer of hyaline cartilage. So the hyaline cartilage lets everything kind of move smoothly, and then the fibrocartilage absorbs all the shock and the weight of you walking or just your weight in general. So create spaces and absorb shock. That's kind of the point. There's no blood vessels inside the fibrocartilage, inside those discs. And one of the bad things with intervertebral disc, especially if you're at a job where you sit a lot or you're just at home sitting a lot, is they do get compressed. So they're, great at absorbing shock and whatever, but then eventually, as time goes on during the day, they just get squished and squished and squished. And as they get more squished, that's more compression, less nutrients can get in there. Since there's no blood vessels going into it, the nutrients have to get in from the outside, from right around it. And if you get no nutrients, those chondrocytes that make the cartilage, they'll start dying off, which means they won't make as much, extracellular matrix, which makes up the cartilage, and eventually you actually get broken down cartilage, which would be bad. Have y'all heard that? When you get older, you get shorter? That's because these discs get shorter. That's the main reason. It's not that your vertebrae are changing size. It's our little discs that are just shrinking and shrinking.
Does that happen in your knee joints too?
Definitely your osteoarthritis, your cartilage does break down as you get older and get less thick all over. And one reason this isn't so bad is every night when you're asleep, when you have no pressure on those vertebrae, they do kind of stretch back out. They're able to kind of squeeze back out. Most of the time when you're having like a sore back and stuff, it's from the muscles. So maybe you twisted a certain way. Could be like, if those discs are slipped at all or a little out of position, that can put a lot of strain on the muscles around them. And there is actually real kind of biological evidence that doing certain stretching or doing yoga stuff, all those different poses and movements relieves that compression. Because you're upside down or stretching in certain ways, and it lets nutrients get into to that cartilage. So there's a lot of, at least some, doctors, if you come in with a slip disc, they don't say, let's do surgery right away. They say, do these stretches, do this yoga, strengthen your back. Don't sit all day in a certain, at a computer or something. So there's stuff you can do to keep those discs healthy. Which, if you ask any of your, parents or grandparents, they probably tell you that their back hurts sometimes, right? So. Yeah, that's.
Okay. Lisa word.
All right, so different parts. We'll look at a picture of in a second. We've got the body, which bears all the weight. So this is the parts. So every vertebrae has these parts. It's got a body to hold the weight, an arch to protect the spinal cord, because your spinal cord, it has bone all the way around it. And then it has processes, which are things sticking off of the vertebrae to attach muscles, and also the vertebrae above and below. And you can see that here. So we've got a top view and a side view. The body's the biggest part of it. So our disc would be right here on top of the body. invertebral disc we were talking about. Right there, the arch is right here. So the arch and the body together protect the spinal cord, and then all these different processes stick off to attach muscles or for the joint between the vertebrae. And so this is looking at kind of the side view. Where's our? So you can see like right here, this is the process of one vertebrae with the one below. And there's a connection right there, like a little joint to connect them. So it's a little confusing because you've got the disc, but that's not really where the joint is. The joint's a little bit away from it on a process of the vertebrae. And it's not on your test or anything, but a slip disc is when part of this disc gets squished out. And so then there's less of it in here to provide the cushion, and you'll get nerves that'll get pinched in there. Has anyone had a slip disc in here? Is it pretty painful?
Yeah, that's all they did. They didn't tell her any stretches. She just did zero.
Really?
Yeah, it hurt. And my grandpa had to get surgery because his discs were so far they're pinching on the nerves. They tried to burn them, and then they ended up
Like burn the nerves out, the pain nerves?
That, but then they had to go in and like file down the bones to clean it.
Oh, wow.
Even have a disc.
That's crazy. Yeah, this is definitely one of those aging thing that is just not nice. It's like,
My brother-in-law was 23, and they fused his lower four lumbar.
really?
Four of them.
Because the discs were messed up?
He was 23, and they were all gone. And his screws, when his bone healed back around it, it grew back too strong, and it snapped all those screws in the tooth. And yeah, now his back's worse off than it was before. Yeah, it's from a military injury, but yeah, but he was too young. He was too young to put those screws in.
Oh.
Bone, they drilled in, it just grew back.
So it was like a blunt force trauma or something that damaged them, or?
It was from carrying a pack.
Uh-huh. And it just like hitting right there.
Yeah, and then doing like working out and stuff all the time.
Huh.
And not being, it was crazy. And then jumping on planes and they hit the tarmac.
Yeah.
Wow. Screwed his back up. That sucks.
Yeah, because once those discs are gone, there's no
Yeah, 'cause he was
there's no getting them back.
he's like disabled now.
Yeah. Wow. That's depressing.
I know, it's really sad. It sucks.
All right, so take a look at this picture. I want to know which of those labeled structures might be attachment sites for muscles. And I'm going to give you some choices in a second. So maybe you want to write down if you think it's more than one. Actually, maybe I should write the choices on the board. All right. All right. So here's your choices. There's our picture. What do you think the answer is? Oh, everybody's voted already. All right, so I want you to talk to your group there, see what everybody came up with, and vote again. final vote. So it is B there. So B is for muscles, D is for muscles, A is the spinal cord, C is the body, and E is there to attach the two vertebrae together. It's like the joint between two vertebrae. I mean, we've got this guy you could look at. I don't know how big, it's not really big enough to tell though. But you can see the discs in here. And then if you look on the back side, you could see all these processes sticking off for the muscles to attach to. And then you can kind of see the joints between like one vertebrae and the next. All right. So that's it for 7. Y'all can go home. Just joking.
Thank you.
So in the interest of time, I didn't make you a quiz today. You all get no grade for the quiz, because I don't have a quiz. Because we're behind, we just used 20 minutes for chapter 7. Because you have a test on Thursday.
Let's just take the quiz.
You see. All right, so chapter 8 is all about the appendicular skeleton. So we did all the axial stuff last time, which is the middle. And then appendicular, it's a little confusing because we tend to think it's just the appendages, but it also includes the bones that attach the appendages. So like your hip bones here, that's part of it. And then your clavicle and your scapula are part of the appendicular too. So everything up there that's in white is appendicular. Everything in blue is the axial. So we're talking about appendicular. All right, so we'll start up top. And we'll probably go through this pretty fast because I think y'all know a lot of these bones already. So if you zoom in here, you got your scapula. You feel your scapula back there? So that's like your shoulder blade. And then above it is that bone that goes right across here. You kind of feel it. It's your clavicle. And of course your clavicle, it's one of the most commonly broken bones, in like contact sports especially, because it's very easy to just fall on your shoulder a certain way and just snap that bone. Because you can tell it's kind of thin, it's kind of exposed up here, right? Yeah, and it's sort of just floating there. It's not like, I mean, look how big your scapula is. You think you break that very often? Like probably. Very seldom. I don't think I've ever heard of anyone breaking their scapula. And one other thing we're talking about is the different joints. But we'll get to those in a second. So the collarbone, two main joints the collarbone has. you've got your SC joint here, and that's between the collarbone and the sternum. There, and then you also have your AC joint, which attaches to the scapula, kind of back, sort of on your, you'd think of like on your shoulder. That's sort of the AC joint there. And this is also one, if you're doing any kind of throwing, baseball, football, that's often a joint that can get damaged, that AC joint, or sprained or dislocated. That's Tony Romo from last year with a broken collarbone.
Makes me happy that you picked a picture of Tony Romo.
Yeah, I don't like Tony Romo very much, so.
Leave my man alone.
Look at him, he's such a wuss. No, I'm sure it hurts really bad.
I laughed at that too. That's the first thing I thought of when I saw it.
Then the joints for the scapula, which is back here in blue. Of course, green is ribs. Blue is the scapula. AC joint again, attaching to the clavicle. And then there's also the glenohumeral joint that actually attaches to the humerus here. So your arm is actually attached to your shoulder blade. That's the main kind of attachment there. It's not really attached to the clavicle there. Even though it kind of feels like it, the actual joint is back here a little bit. So your shoulder's attached to your scapula. Does anyone know what those muscles are called that hold all this together up here? Something that you always hear about being torn or strained. Yeah, it's at least a lot of the muscles that hold that all together, the rotator cuff muscles up there. There's other ones, but those are one you hear about. Right, and if you go farther down, got your humerus, which is the upper arm, got your elbow, and then down below you have your radius and your ulna. What do you think's a good? Does anyone know a good trick for telling them apart? So your radius is on your thumb side. That would work if you remember that. It's also confusing, right? You don't want to say one's closer to your body, because if you turn your hands the other way, it switches, right? So if you know the anatomical position, which one's closer to you if you're like this? So in that position, the ulna is closer to you. So I'll need to remember it. But remember, you gotta be in the anatomical position if you remember what that is. So those are two ways to remember them. Great. And then if you come, I'll get to the bottom in a little bit. An interesting thing about your radius and your ulna is it's connected in 3 places, those 2 bones. So the first one is close to the elbow. It's the radio-ulnar joint. And then all along, like your forearm, all through here, there's a connection of fibrous connective tissue to keep them tied together. And then there's another joint closer to your wrist, which is the distal radio-ulnar joint. And this membrane between them, it actually changes shape when you're doing this. It's kind of interesting. So like, if you're turning your arm, when do you think those 2 bones are closer together? When you're like this? When you turn your hand over? I already forgot what I asked you. Did I say closer together or farther apart?
Closer together.
Okay, when are they closer together?
Down.
Yeah. So when they're like this, that connective tissue gets kind of tensed. And when you're like this, it actually relaxes. So it allows you to move it, but it helps to hold those two bones together. Because obviously that could be sort of a weak point, right? You wouldn't want all the stress just on the joints in your wrist and the elbow. You want to keep those bones connected together if you can. But you still need to be able to move it, so you get this sort of connective tissue connecting it to let it be strong, but also somewhat flexible. And that's the interosseous membrane. What do you think interosseous means?
Between bone.
Yeah, it means between bone. Then if we move a little farther down, not going to make you memorize all the different wrist bones. We'll just call them the carpals. If you want to be like an orthopedist or something, maybe you'll learn those. And then the bones of your hand are the metacarpals. Kind of, you can feel them, right? Feel your metacarpals up in your hand there. So carpals, metacarpals, and then the bones of the fingers are the phalanges. Each of your fingers, how many bones do each of your fingers have? So it's got 3. What about your thumb? So your thumb's got 2, fingers have 3. It's kind of interesting. It's funny that they have these tiny little phalanges at the end, but it's good for gripping stuff, right? Like, think how much better you can grab stuff with your fingers than your thumb with only 2 bones. You can't really grab things with just I don't know, it makes it easier. Right. So, which is the correct sequence of bones from your upper limb from proximal to distal? Toss in some of those vocab from chapter 1, Larry.
Every time I hear the word phalange, I think about TV and Friends and their alter ego.
Really? I haven't seen that. I don't really like Friends.
Watch Friends.
Mm-mm. All right, so B's right there. Sorry, forgot to eat lunch. All right. Any questions on the upper body up there? It's pretty straightforward, I think. All right, so spend a little more time on the lower body because I think the pelvis is a tad more complicated. So probably the largest bone in your body in terms of area, just because it has to connect your whole upper body to your legs, absorb all that force. So we've got our hip bone here. There's the sacrum and the coccyx at the bottom, which are your last little fused vertebrae. And then coming up into the hip bone is the femur. And then let's see, what did I put on there? So we'll talk about it more, but the hip bone does have 3 regions, even though it's one bone that is on your list there. So you've got the iliac up here. You've got the pubic bone down here. And then you have the ischial region sort of in the middle. And we'll have a little image of it labeled, those 3 places, in a little bit. And another thing we'll talk about is the pubic symphysis, which is right here between the pubic bones, and that's more fibrocartilage. We'll talk about that later too. All right, so the parts, we get the ilium, which is the most superior, so that big wing on the top. The ischium is between it, and then the pubis is kind of the middle and the bottom of the hip bone. Before we do that, let's look at this. Back up here. Look at the pelvis. And this one's nice because it'll highlight it for you. So there's your ilium right there. You can see it in orange. And then the ischium is kind of between it. And then the pubic portion is the middle, more or less, in green there. And then the pubic symphysis is right there in blue. You can see it right between. And sacroiliac, this is a really common place for people to get nerve pain, especially when they're older. And that's the joint between the sacrum and the hip bone. So it's like highlighted in red there. So it's, it is a joint. It's mostly immovable, but it does have cartilage. And that cartilage can break down, and you could get nerve pain from there. All right, so you got an idea. So why do you think it would be bad if the pubic symphysis was made of hyaline cartilage instead of fibrocartilage? All right, so why don't you chat with your group there and see what they're thinking. All right, final votes out there. All right, so the answer is actually A, which more people chose the first time. So I heard some people whispering around, what's the function of this pubic symphysis thing? Yeah, so it's to absorb shock during walking. And if we look back a little bit, I'm no engineer, so I can't say I understand this completely, but because of the shape of this hip bone, whenever you take a step, your foot hits, a lot of the force is directed this way, and it's just absorbed by the fiber cartilage and then released when you're, take another step. So kind of like a little spring that goes in and comes back out. And that's better than transferring all that weight to this joint up here, because there's no fiber cartilage up there. You don't want the weight up there. So instead you have this. Now, fiber cartilage, that's what it's designed to do, right? Is squeeze, absorb, and then release. If you only had hyaline cartilage, it would just get squished too easily. And so then, potentially these bones would bang on each other, which would probably be really painful, I'm guessing. So it's made of fiber cartilage. Fiber cartilage absorbs shock really well. That's kind of how its structure supports its function there. All right, so one of the biggest differences between men and women, and at least in the bone area, is the pelvises are different. So we got a little movie, and then we got some more pictures. This one's interesting because it's actually like a real pelvis, I think. I don't know why people put in their little thing.
This video is about the differences between the male pelvis and the female pelvis.
What do you see right away? So which one's more open? The female's more open.
So to start off with, we're going to look at the pelvic inlet, which is described by the pelvic ring here. And
So when they say inlet, they're talking about basically they're talking about birth. So the baby comes into the pelvis in the inlet. That's why it's called the inlet. So it's kind of the top, like the superior portion.
it is larger in a female than it is in a male.
They're really making sure you're paying attention. They're like,
Now, when we look inside, we can see the curve of the sacrum of the coccyx in a man is much more anterior than a woman, where the curve is straight down.
mm-hmm.
So, the ischial spines in a woman point posteriorly, whereas in male pelvis, they point medially.
I'm not sure you can see that very well in that picture. Can you see that? I guess.
In the anterior view, we can see the subpubic angle, which is this angle right here. And in a man, it is much more narrow. In a woman, it is much wider. Now we're going to take a lateral view. The greater sciatic notch is here, and it is much wider in a woman than it is in a man.
So they're talking about, the space going through there. You can see it's a lot bigger in the female. Here's just, so you have the image of it. You can see that that's the female sign, that's the male sign. This opening's a lot larger and less obstructed in the female than the male. And also this pubic arch is U-shaped and more open, and the female as well. Why is it different? So to let the baby out, because us men, we don't have to have babies come out, so we can have different pelvises. So which of these pelvises do you think is better for walking and running? And what do you think? So it would be the males. So there is like a trade-off, right? We can have, us males have the slightly better pelvis for walking, for running, but that pelvis wouldn't work for having babies. So the females has to be at least somewhat different in order for that to work. And interestingly enough, there's, if you look at, like Homo sapiens and then back to Homo erectus, the humans that we kind of evolved from, their pelvises got larger and larger as the babies' heads got larger and larger. So if you look at like Lucy, you heard of Lucy before, like that ancient skeleton they discovered, her pelvis is really small, and so is her head. So like that form of humans had narrow pelvises and narrow heads. So they had to kind of co-evolve together because we need big heads for our big brains, but they have to be able to get out because otherwise you can't pass on that big brain gene. So it's kind of interesting sort of trade-off there. I think I've heard that that's a fallacy.
I've heard it, but I don't think
Yeah, you always hear that, like, oh, wide hips, easy to have babies. I've heard that that's not actually true. Because what really matters is what's the inside, like how big that hole is. And that's pretty standard. And something, when we went to, all like the hospital birth classes where we had our kids, is that there's a lot of, they used to say, oh, there's certain shapes of pelvises that are better for giving birth, or they would, do a little sonogram or something and say, your pelvis is in the right shape. And then they actually studied it and they're like, it doesn't really matter. But there certainly is occasions where, some people do have larger or smaller pelvises, pelvic openings to make it easier or harder. All right, so what happens during childbirth, or at least close to the time of childbirth? That sacroiliac joint loosens. Do you remember where that joint was? What two bones? It's the sacrum and the ilium. So that loosens a little bit so that that cavity can expand a little bit. And also that pubic symphysis, that was between the pubic bones, it actually widens by a few millimeters. So those pubic bones can actually spread apart. Right. Should we watch a baby getting born? Don't worry, it's not a real image. It's not a real video.
It's not the one from the class from high school.
No. It's kind of a fun animation because you could see the pelvis change shape a little bit. Uh-oh, that's inappropriate. No, no. No one saw that. This is like Lord of the Rings. I think we should turn the light off. I can't see it. So you could see like the joints loosening, the symphysis getting wider, and then we don't have to watch the whole baby come out. But those are really important adaptations and changes that if you weren't able to do that, that baby would get stuck. But that also allows, it allows that female pelvis to stay pretty well adapted to walking, running. And then just for childbirth, it can open itself up a little bit and then close back to be normal again. Yeah, I think that happens somewhat often. Yeah. I don't know how common, but it's pretty common. And also that pubic symphysis can become somewhat separated too. And it'll take it a while to kind of get back together. Mm-hmm. Really? Wow, that's great. So how did her hip, or how did her,
It was her, like, her tailbone.
oh, her tailbone broke? Yeah, I think that happens somewhat often.
Yeah, you feel like a lot of pressure, like that's where you're sore. Like that's plenty of food to keep you sore.
Well, I mean, if you looked back at that picture, you know, it's kind of in the way, right?
Yeah.
Like there's the sacrum just sitting there in the way. So it can, you know, come out some, but it's still getting pressed on a lot.
Is that what the waddle's about?
Go ahead.
The waddle? You're like really pregnant.
Yeah. Anyways. Any other baby questions? So it's just a kind of a cool thing that your body can do and your bones can change. All right, so moving on down. Got your femur, and this is what we were looking at on our chicken bone, right? You had the femur there, the drumstick, and you saw the knee joint part. And I think the hip joint, it was probably cut like, did you have part of your hip bone in that, your chicken drumstick? It depends on the one you got. Sometimes they'll cut it here, sometimes they'll cut it a little bit there. Just kind of depends. Let me turn. So you go femur, knee, and then we've got our tibia and fibula. These are always confusing for people, I think. If you reach down, what do you think your shin bone is? You're going to feel it. Do you think that's your tibia or your fibula? So that's the tibia, and then the fibula is kind of more out to the side. Well, you can tell by how big it is that it contains a lot less of the pressure, which is why it's so thin. I'm sure it's got a little bit, but definitely not near as much.
It's only there to support your right?
It's actually ligaments that are supporting your knee
Yeah.
joint more.
Yeah, I mean, but like that's where it does attach to, right? Like,
It attaches to both. But you're right, the major weight-bearing portion is the tibia there. And if you notice, how many connections are there between the tibia and the fibula? So 3, it's just like your forearm. Joint here, interosseous membrane, joint there. Go down farther. Before we go on, why do your arms and your legs look so similar, in the bones at least? Which one used to look like the other? Your legs used to look like your arms? Right? I mean, we used to be quadrupeds, right? So our arms used to look like our legs, or at least pretty similar. And then as you evolved to be upright, you don't walk on your hands anymore. So these structures can be more adapted to grabbing things, moving around. They don't have to support any weight anymore. So it's kind of how those bones change. But you didn't change the basic structure, right? We still got one larger bone, two smaller bones connected together. Then as we move down, we've got the tarsals, which are the ankle bones. Then you've got the metatarsals, which are the bones of the foot. And then you've got phalanges again for your toes. How many phalanges do you have for each toe? Still 3. It's just, look how, I mean, it's hard to believe how, some people have such short toes, but there's still 3 bones in there.
That's what I'm doing like right now. I'm like, I don't even know how much.
3 little bones in there. All right, so the last thing before we get to our bone game again is the arches of the foot. So as you know, your feet aren't supposed to be completely flat, right? It's not really a good thing. So we've got 2 main arches. We have the longitudinal arch. That's the one you think of. That's the front to back arch. And then you also have a transverse arch, which is kind of left to right across the foot. And you can see that here. So here's our longitudinal arch, and then the transverse going from left to right. Which one's more prominent, do you think? So like the longitudinal one's a lot bigger, but there is the transverse as well. Kind of an interesting one. Or I guess I should talk about the point of it. What do you think the point of having the arch in your feet is? So some is to distribute weight, and another part of it is shock absorption. So because you've got this shape here, these bones and these joints can absorb a lot of the weight when you're walking. So they can kind of go down a little bit as you're taking steps and then kind of spring back. So it's sort of an automatic shock absorber. So you don't have to absorb all that shock in your ankles, your knees, your hip bones, all that. You could start absorbing it there. How does that look? So normal arch, no shoes or normal shoes, you get about 50% of your weight on your ball versus the heel of your foot. That's what it's all designed to do. If you put on some heels or something, those are some pretty big ones, you get like 90% of the weight up on the ball of your foot. What do you think that does to the front of your foot eventually? It's definitely gonna make it hurt, and you could, long term, like if you're wearing huge heels every day, you do end up with foot problems up there, because now you have all this weight on the front of your feet instead of back here on the ball of your foot or the heel. So probably wouldn't wear. I only wear heels once a week, so just to make sure. All right, correct order of bones from proximal to distal of your lower limbs. All right, so it is A there, nicely done. All right, so let's do a card game again. And I've got, where's my rules? You had rules last time too. too slow. Words. All right, so round one through there, you're going to take turns. One person's going to pick one up, describe it. Everybody else has to guess it. Feel free to keep score if you want. After you go through all the bones, round two is only pointing. And number three is you get to draw it on the table. And I owe some, I think I'm short. I didn't cut somebody's up. Okay. Curry's up. Should be fun.
This is gonna be a lot more fun, I think, than the nasal bone one. The nasal bone one is hard.
Yeah, those are a little more
Well, you
confusing.
can't point to them really, because they're like embedded in your face.
Yeah, but that was fun.
It was
I enjoyed
fun.
watching. I'll try to point at those
Like,
things.
it's up here.
All right. There's your stack. There's yours.
Yeah.
Yeah.
Okay, let's start.
Yeah.
It was
So if they're Sally.
on this one. I didn't know.
Oh, I don't think we talked about
It
that.
wasn't really on the side, you know. I
Yeah.
was looking at that.
I just wouldn't worry about that one then.
What is the question?
The pelvic girdle, since we didn't go over that.
Joints in the bone.
I want to make sure I don't try to split it out.
We did do the ones for the shoulder though. Right.
Like the shoulder and the crossbone.
And then which joints? Yeah. AC, SC, the glenohumeral. That word.
Gas?
No?
Okay.
I hope not. Oh, and yeah, all these bones are the appendicular ones in the stack.
Oh.
The ones we've been doing today. Yeah.
Part of your hands.
What? You don't get to choose which one?
Oh, we don't? Oh.
What kind of card game do you get to look at all the cards?
Alright, it's.
The sacrum of the butt was not huge.
Mm-hmm.
Right?
Yeah.
Before we
Right. Because then you should have, you reviewed all of them. So they should kind of be in your head.
This is my son's x-ray. 'Cause
Okay.
He had his scapula taken out.
Taken out?
Yeah, well, he had cancer there.
Oh.
So his clavicle's free floating. And it ended up forming to wrap around his top of his arm.
Wow.
Yeah, the surgeons were really surprised that.
So is that a good thing?
Yeah, because since they had to take out the scapula.
The whole thing?
Yeah, they moved his arm and then it's attached to his chest wall.
Oh.
Yeah, so it's right attached to the.
Wow, I've never heard of
rib
that before.
Yeah.
And he can move around and he can still use it pretty well.
Yeah, he just can't lift up straight up. He has to assist.
Well, it's not too bad.
Yeah, he does. He manages real well. I mean, he still does sports and everything. So he has to still form some scar tissue and stuff before he can really get range of motion. But
Is that the left then?
yeah,
He's right-handed?
yeah, that was a good.
Well,
Thing, yeah.
That's a good thing. Yeah.
And
A cup?
Their hips? No, not that.
yeah,
I know what cup
that
is.
does
That's
ridiculous.
it.
though.
But isn't there
For
something
baseball.
that? It's called like a girdle.
But hip
I don't know.
pads.
Yeah,
Yeah, hip
is that what
pads.
it is? Because Elliot has those. Like, it's like,
Yeah.
oh, that's my. Like, that sounds disgusting.
Girdle is
But
like
they-
you
yeah,
put
they
your
do.
hip pads into.
Yeah, okay.
Or they
Okay.
come with
I like
hip pads
found the
already built
pants
in.
that I was like doing laundry.
Did they have
Yeah.
things in them, like little spongy things?
Huh.
They come up with some pretty lightweight stuff.
Pockets all over there. What is this? And it's like, oh, yeah.
He's like, that's my girdle.
Fit your pads.
Yeah, it's probably good to have a pad there. 'Cause it's a pretty common place to just get hammered or crash. I mean,
And it's called patella?
it is a bone.
That's part of it. I always get patella and peddler or whatever.
Oh, the petal. Yeah.
It's your arm bone. Humerus. Yes. I like how we both got that. I know.
Alright.
Did I put patella on there? Oh, I did.
It connects to your shoulder blade. Here. Kind of weird. I didn't never know that. Now it's like creeping me out when I sit here and
I don't know what the prefix meta means.
I don't either. I can't remember. I'm in medical terminology. I should probably know that.
I should look it up. Let's see. Oh. You can call me Mr. H.
All right, Mr. H.
Yes.
Which one is the fibula and which one's the tibia? The tibia is the shin bone and the fibula is the little one.
The tibia's right here, right?
Or the fibula is the big one and the tibia is the little one.
Like when
Well, I
you
think you're saying one of them wrong. So your fibula is the shin bone, and the tibia is out on that side.
Ooh, the fibula. The fibula is the shin bone? Yes. I thought it was the tibula. No, it's
Tibia and
Tibia.
fibula. This is what they sound so similar. You get them combined.
Okay, so what's this?
Wait, did I just tell you backwards? I told you backwards. I always get it backwards.
That's what I
Yeah.
What was it?
So tibia is your shin bone, fibula is the other one.
Fibula is the skinny one. That attaches to the tibia. Right?
And you know what people write in their test? They'll write tibula.
And it's tibia.
Yeah, because they'll put like the two words together, and I'm like, well,
Right? If we do
no, because I don't know which one you mean. Or if you write fibia, I don't know which one you meant.
the tibia is the shin.
The shin.
And then the fibula is the little one.
Fibula is the one that's on the outer side of your leg. Fibula is the outside? Yeah, the little one.
The one you don't really feel so much, you know, it's hard to feel it. Really? That's funny because I was like looking at the diagram.
Because she even wrote it down the same thing.
No, she wrote it down the right way. Rosa's got it. See? It's hard. It's just those words sound so similar. It's really easy to get them
You
backwards.
know what? I'm just going to go with this and rewrite it.
That's so weird that I got all the leg bones. That's true. Yeah, here. Okay, so now we gotta draw them.
That'll be fun.
Oh, okay. These guys.
How much is it?
Oh, no, wait. Oh, I'm sorry. I'm not going to the right thing. Sorry, that's my
Tibia, shin bone, fibula, small outer bone. Okay, next one. Let's play it again.
Dog bone. Dog bone.
Always give me that one. That is a hand.
That's only got 4 fingers.
Oh, I look at my baby.
So that's the radius. So you did it like this then.
Okay,
So the radius.
she's
yeah.
always like.
Radius.
Sorry, I'm not sorry.
Alright.
You're correct.
Phalange, phalange.
And then when you can do a little
Do you know where the term funny bone comes from? Is it because I mean, it's not, I know it's not funny at all. And it's not
I don't
even
know why they
offensive
call it that.
or why they call it that. It's not funny. I hit my
I don't know. It's really weird. I agree.
It makes me mad.
Yeah, because there's no such bone as the funny bone.
Yes, leave my foot alone.
Where's the arch? It's a flat foot. Yes.
Where are we taking our test for Thursday?
Oh, that's a good question.
Let's say.
I better go see if I can reserve that room.
Because it was kind of like, wow, you know, I need somewhere to like, at the same time, just over there, somewhere quiet.
Thursday? Computer labs. You already know? Okay. Oh, okay. Yeah, so we'll be taking it in here then. But you can take it in there.
We might can move lab 2, so I'll check lab 2 and see.
Okay. I'll ask Beth. Okay. That's bad. Yeah, but if not, you thought it was too loud in here?
I was starting to test and everyone was still like trying to get their
Oh, right.
going and they were talking and then it's just like distracting.
Yeah, I mean, is there people there that are watching you?
No, it's just, oh, where?
Like in the testing center? Yeah, if there's some...
In the office? Or is it the one in the Well, they're watching you in both.
Do I?
They're watching you in.
Yeah. Okay. Yeah, if you ask them, I don't mind. So yeah, check in and send me an email. What?
It's a lake.
Okay.
Okay, it's right here. Oh, yeah, okay.
Oh yeah, let me get a orange or a pink. Thank you. It's gonna be big bone, little bone, little bone.
Oh, I know what that one is. I knew it right away. Yep. The part of it, the ischium.
Ischium?
Ischium. Mhm.
Oh, ischium. What is words or something?
I know. All right. All right. So go ahead and stop there. Let's talk about our test on Thursday. No. Why would I do that? All right. So I'll give you some helpful tips. So obviously, some people may need to do a little better on their test on Thursday than in the first one. So study tips. What do you think you should do for studying? So flashcards would be awesome. Could answer the study guide questions. Probably at this point, a good thing to do would be to print out a blank study guide and try to answer it without any help. No books, no notes. See what you know already. And then circle the ones you don't know, go back and figure them out. Do the same thing. You could kind of do the same thing with flashcards as long as you're not reading the answers. Like you force yourself, you see the objective, you're going to say the answer, and then you're going to check yourself. What doesn't do much is to just read it, read it, read it, read it, go to the next one. Because your brain's not doing anything with it. Your brain's like, whatever, this is boring, I'm thinking about something else. That's what your brain's doing. Also, do you think you should stay up all night on Wednesday? Don't stay up all night. Your grade's probably going to be a lot better. What do you think you should do on Thursday morning, if you can? I wouldn't study very much. Eat a good breakfast, get some exercise, sleep on Wednesday. You want your brain to be fresh and happy when you come for your test. And last, email me if you have any questions with any of the study guide things. And then you should be fine. Because you've seen the test, you kind of know what they're like now.
Will it be about the same amount of questions?
Yeah, it's a similar test.